The first homework question we're going to look at is page 37, number 4. Chang arrives at the giant auction sale late in the afternoon. There are only 5 items left to be sold. How many different purchases could he make? Okay, so in number 4, there are 5 items left. So notice, let's call those, and we're assuming there's 5 different items. So let's just call them A, B, C, D, E. So how many different purchases can he make? Well, they're not telling us if he makes 2 purchases. They're not telling us a number of purchases. It could be anywhere from 1 to 5 purchases. So he could either buy A, he could either not buy A or buy it, not buy B or buy it, not buy C or buy it, not buy D or buy it, and not buy E or buy it. So there's 2 choices. The number of choices, right? Number of choices is 2, 2, 2, 2, 2. So we have 2 to the exponent 5. Assuming he makes a purchase, we're going to subtract the possibility of 0 purchases. So that will equal 32 minus 1, and that equals 31 possible purchases. Okay, so we are subtracting 0 purchases. We are assuming he makes at least 1 purchase. We're subtracting the possibility of 0 purchases. Okay, number 6. 12 dots are on a page of Ruth's dot-to-dot puzzle book. If no 3 points are collinear, how many straight lines can she form by joining the dots? So they're just saying no 3 points are in the same straight line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'll squeeze in another one here maybe. But what they're trying to say is no 2 points are in the same straight line. So no 3 points are in a straight line. So we could make a line that way. How many points do we need to make a line? 2, right? So there's 12 in total, and we choose 2 of them. And so there are 12 NCR, 12 NCR, or 12 choose 2 ways, or I get 66. Sorry, my paper shifts. 66 ways to make a line. 66 lines. You have 12 dots to choose from. You need 2 of them to make a straight line. So there's 66 lines. Number 14. Maria's bag of marbles contains 2 red, 3 blue, and 5 green. If she reaches in to pick some without looking, how many different selections might she make? Okay, so she has 2 red. This is page 38, number 14. She has 2 red, 3 blue, 5 green. Okay, so if we look at that, how many different selections? They're not saying, oh, she's going to pick 2 marbles or 3 marbles or 4 marbles. We don't know how many. She could pick anywhere from 1 to 10 marbles. Okay, so you could either pick 0 red, 1 red or 2, 0 blue, 1 blue, 2 blue or 3 blue, 0 green, 1 green, 2 green, 3 green, 4 green, or 5 green. So notice there's 3 choices, 1, 2, 3, 4 choices, and 6 choices, and we're going to minus 1. We minus 1 to ensure a choice. right? And we will have 24. 3 times 24 is 72. Minus 1 equals 71 choices. Or 71, using their terminology, they say selections. And hopefully those answers are right. Yeah. Okay. Let's take a look at number 17. Page 38, number 17. In Lisa's first year college program, she must take 9 courses, including at least 2 science. If there are 5 science courses, 3 mathematics courses, 4 language courses, and 5 business courses from which to choose, how many different academic programs should she follow? So let's look at this. Page 38, number 17. She must take 9 courses. That sounds like a heavy load. And at least 2 science. Okay, so she needs at least 2 science courses. There are 5 science, 3 math, 4 language, 5 business from which to choose. How many different academic programs should she follow? So assuming I wrote 5 science, 3 math, 4 language, 5 business, has to take 9, at least 2 science. So what I'm going to do is I'm going to do it the direct way. Let's do it both ways, direct and indirect. And, well, indirect might be a challenging way too, but let's just see. Let's try both. The direct way is where we're basically adding up all the cases. Indirect involves subtraction. Okay, so notice there's 5 science, and then there is 12 other courses to choose from. So now she has to take at least 2 science, and she's taking 9 courses. So the direct way would be she takes 2 science, or she takes 3 science, or she takes 4 science, or she takes 5 science. That's the maximum number of science courses she can take, because there's only 5 science courses to choose from. So if she could take 2 science and 7 other, right? Or she could take 3 science and 6 other, or 4 science and 5 other, right? Or 5 science and 4 other. So that means out of the 5 science, she's choosing 2, and out of the 12 other courses, she's choosing 7. Out of the 5 science courses, she's choosing 3, and out of the 12 others, she's choosing 6. Or out of the 5 science, she chooses 4, and out of the 12 others, she chooses 5, and 5, 5, and out of the 12 other, she chooses 4. So if we were to work that out, that should get us the right answer. So 5 NCR 2 times 12, NCR 7, and I get 7920. 5 NCR 3 times 12, NCR 6, and I get 9240. 5 NCR 4 is 4 times 12, NCR 5, and I get 3960 plus 12 NCR 4 times 5, choose 5 is 1, so 495, and I get and I got 21,615. 21,000. This is number 17. Okay, now let's try that just to illustrate the indirect method. It might be a little less work. Yep.
I think there's a faster way to do that. But if you just, from 5 science courses, you choose 2 and consider the rest of the courses as technical courses, then the answer is like 5 choose 2 times, like, for example, 15 choose the rest, if you choose 7.
15 choose 7.
Well, yeah.
15. Okay, this is another possible answer which I'd like to investigate. Do we get the same answer? Let's see. I know this is the correct answer. Let's see if we, an interesting point has been raised. This answer is a bigger answer. Okay. This is a common error made by students. The problem is doing it this way, you're introducing an order. So when you start having order, your answer is bigger than when you're actually just choosing. So let's say, do you understand why?
Yeah, because I just kind of placed the 2 sides at first and then placed the last.
Okay, I'm just going to lay it out. Let's say in the 5 choose 2, let's give the science courses a name. There's 5 science courses, A, B, C, D, E. So when in the 5 choose 2, let's say I pick A, and in the 15 choose 7, let's say I choose B. And then in the 5 choose, and then I pick the rest of my courses. Like if then in 5 choose 2, if I choose B, I could choose A here. Like you're starting to introduce an order which doesn't work. Okay, so that's why it's so important to break them up into cases. Okay, that was just an aside. Very interesting point and an issue a lot of students run into. Let's do the indirect method. Okay, so we could go total possibilities minus 0 science courses minus 1 science course will leave us at least 2 science courses. Okay, so that's another way we could do it. It's important to, so we should end up with the 21,615, doing it the indirect way. So there are 17 courses to choose from, choose 9. And out of the 0 science, we'll choose 0 science. So out of the remaining 12 courses, we'll choose 9 courses, minus 1 science, and out of the other 12 courses, we choose 8. And that should get us the same answer. And I'm just going to double check that. Make sure there's nothing I'm overlooking. That's 21,615. Okay, so that was number 17. And the other question that was asked was number 23. Okay, 23. We'll start with, this is page 39. Here's question 23. Calculate the number of diagonals of a hexagon, and then we'll use the pattern we find in 23 to answer part B. If a polygon has 35 diagonals, how many sides does it have? Okay, so we have a hexagon. 1, 2, 3, 4, 5, 6. A hexagon has 6 sides. So they're wondering how many diagonals does it have? So these are the diagonals, right? The diagonals are all the dashed lines. And there's that one, right, and that one. So that's 6 plus 2 is 8. And the answer I get is 10 by drawing. But let's do it. We're going to go total lines formed by 6 vertices. Right? 6, choose 2. We only need 2 points to make a line. And we're going to subtract the number of sides, which is 6, right? 1, 2, 3, 4, 5, 6. And we get 6 NCR2 minus 6 is 9. Okay, now let's do 23 part B. If we have 35 diagonal sides, how many 35 diagonals? If we have 35 diagonals, how many sides does it have? So we're going to follow this format. This is equals number of diagonals. So the number of diagonals is equal to, we're going to say n vertices, choose 2, minus the number of vertices. So we can say n equals number of vertices, which is equal to the number of sides, right? So we have 35 equals n factorial over 2 factorial n minus 2 factorial minus n. So let's simplify this and solve for n. Have to get rid of the factorials, right? Before we can solve this. So this divides out, and we're left with 35 equals n squared minus n over 2 minus n. Let's multiply everything by 2. 70 equals n squared minus n minus 2n. So 0 equals n squared minus 3n minus 70. We'll solve by factoring n minus 10, n plus 7. So n equals 10 or n equals minus 7. N cannot be negative. We cannot have a negative 7 factorial. Therefore, n is equal to 10. Okay, so that was the answer. I can't fit it all on there. That was the answer to number 23. Were there any other questions that I can go over, or may I explain anything better? Okay.